Hi everyone, and welcome back to chemistry class with Mrs. Rose. Today we are going to be talking about precipitation reactions. You are going to need a notebook, a pencil, and a periodic table, but you won't need a calculator. When you have all of your materials ready, let's get going. So what is a precipitation reaction? It is when you have two soluble salts in solution and they react and form an insoluble product. So let's kind of take a second here to talk about some of these terms here. We have the terms soluble and insoluble. Now, I'm sure we've gone over these before, but it would be a good idea to review these. So soluble means that the chemical can dissolve, which means that insoluble means that it can't dissolve. Now, when we're talking about things dissolving, it always depends on what solvent you're using. For precipitation reactions, we are using purely ionic compounds, and our solvent is always going to be water. So we're using pure water, we're having aqueous solutions, and all of these things are being dissolved in water. Now, let's keep reading. The insoluble product forms a solid and precipitates out of solution. The product is called a precipitate. So we see this word precipitation, precipitates, and precipitate. They're a lot of the same root word, right? But they're being used in completely different ways. So right here, it precipitates out of solution. This is being used like a verb, and this one, the product is called a precipitate. Well, that's a noun. And so what you just have to realize is that this word is really interchangeable. We use it a lot, and you just need to know that it means that a solid is forming and coming out of solution. When talking about solubility, there are lots of rules to help you to determine if a compound is soluble or not. If you Googled solubility rules, you would find dozens, but I'm going to keep it pretty simple for you, and I'm only going to ask you to learn 3. I know, I'm the best. All right, and I have a little cheat for you to help you remember it. It's NAG1. NAG, where the N stands for nitrate, A stands for ammonium, and G1 stands for group 1. So any salt that has nitrate as part of it is going to be soluble. And so let's remember that nitrate is NO3 minus 1. So if you see this as your anion, then you know that it is soluble. Same thing with ammonium. If you see that you have NH4 in your compound, then you know it's soluble. And then any of the group 1 ions will be soluble. So that's H1, Li, Na, K, Rb, and Cs. Okay, so we have hydrogen, lithium, sodium, potassium, rubidium, and cesium. Francium is also, of course, group 1, but it doesn't make ionic compounds because it's too radioactive. So these, what is this going to be? 8 things are always soluble. There are lots more things that are also soluble, but these are the only ones I want you to be concerned about in helping you identify the solubility of a substance. So let's practice this. How are we going to apply that thing that we just learned? The first thing we're going to do is write our little cheat down here just to help us remember. So we have NAG1. So when you see a compound, what you're going to look and see if you have a nitrate, ammonium, or a group 1 metal. So if we look at this first one right here, we have potassium chloride. Well, potassium is a group 1 metal, so it is soluble. Let's look at our second one. Here we have silver and nitrate. Well, nitrate is one of our things that makes a compound soluble, so it is also soluble. Looking at this third one, we have silver and chlorine. That is not part of our rules anywhere, so this one we know would be insoluble. Okay, your instructions here say on your page, write down every compound that isn't soluble. So you're going to go through this long list and you're going to find every compound that does not include one of these things. Go ahead and pause the video and take your time to find all of the insoluble compounds. All right, hopefully you've had time to find all of the other insoluble compounds. So we're going to go through here and find all of our other insoluble compounds. Potassium and nitrate, both of those are soluble. Potassium and chromate, potassium soluble. Barium and nitrate, nitrate is soluble. Barium and chromate, neither of these are on our list, so this one might be insoluble. All right, sodium and sulfate. We're going to underline our sodium there. Lead nitrate. Nitrate is soluble. Lead sulfate. Neither of those are in our solubility rules. Sodium and nitrate, super soluble. Potassium hydroxide has a group 1. Iron nitrate has nitrate. Iron hydroxide has nothing from our solubility list, so we're going to circle it. This one must come out as a solid. Hydrogen sulfate is got a group 1. Potassium dichromate has got a group 1. And then our last one here has a nitrate, so those 3 are all going to be soluble. So our only 4 insoluble compounds on here were silver chloride, barium chromate, lead sulfate, and iron hydroxide, iron 3 hydroxide. Okay, I hope that makes a little bit more sense on how you use your solubility rules to determine if something will stay dissolved in solution or if it will come out as a solid. So, precipitation reactions have a special way that we write them, and we're going to go over those steps for right now. So the very first thing you need to have when you're doing a precipitation reaction is a balanced equation. Then you're going to rewrite the equation with all of the reactants as their individual ions. So you're going to break up your compounds into their individual ions. Then you're going to combine the ions that were not combined before. Be sure to combine a single type of positive and a single type of negative ion. We are forming salts, so you have to have a cation and an anion. And you also need to double check and make sure that the charge of the compound adds up to 0. So you need to make sure you have the right formula. If a product is insoluble, a precipitation reaction has occurred. Sometimes all of your products are soluble, and that means that no reaction has happened, and that's okay. Let's try and put these rules into practice here. So I'm going to do an example problem for you. This is pretty standard of what you can expect to see. So what compound precipitates when aqueous solutions of iron sulfate and lithium hydroxide are mixed? The first thing we need to do is to write down a well-balanced equation with its new formulas. You'll notice that I did not give you the products here, so we're going to have to predict them. Let's start with what we're given though. So we have iron 3 sulfate and lithium hydroxide, and we need to figure out what they form. And remember that I like to do outer with outer, inner with inner. So our new products are going to be iron and hydroxide and lithium and sulfate. But it's not that simple. You can't just be like, oh, wait, that's awesome, I'm done, right? You have to figure out what their charges are. And it's easier to start on this side to figure out what their charges are because they don't change. So here we know sulfate is A-2. That's a total of -6 since there's 3 sulfates. There are 2 irons needing to add up to a total of +6, so each one is going to be +3. Lithium is a +1 and hydroxide is a -1. All right, beautiful. So we know everybody's charges, they carry over to this side. And we need to make sure that all of the charges add up to 0. And if they don't, then we're going to need to do our multiples. So iron and hydroxide do not add up to 100, so it should be FeOH3. Lithium and sulfate also do not add up to 0, so this one is going to be Li2SO4. I don't know why I put the parentheses there. Li2SO4. Beautiful. Now, We need to balance it. Okay, these are all steps that we're fairly familiar with. So we're going to balance it. We're going to make one of my favorite tables. And we're going to make a list. Now we have two different polyatomic ions. Neither of them change from the left to the right side of the equation. So we're going to leave them together as groups. And then we're just going to count them all up. We have 2 irons, 3 sulfates, 1 lithium, and 1 hydroxide. On this side, we have 1 iron and 1 sulfate, but 2 lithium and 3 hydroxide. So basically, nothing is balanced. That's okay. We can fix that. So looking at our iron, we need to multiply this side by 2 to equal 2. And that will also change our hydroxide. So now we have 6 hydroxides. That's okay. We'll think a little bit more about that later. Our irons are balanced. Let's look at our sulfates now. We have 3, 2, 1. So we're going to need to multiply this one by 3. And that will also change our lithium to 6. Well, that's really convenient that both of those need to be 6, because now all I have to do is multiply this by 6 and everybody's balanced. Beautiful. So we have a balanced equation. We have predicted our products, but we are still missing something really, really important. And that is our states. Okay, states are very important for precipitation reactions. It's pretty much the only time I make you guys really pay attention to the states. And let's just remember really quickly that there are 4 states that something can be. You can be a gas, a liquid, a solid, or aqueous. We are going to be dealing almost entirely with aqueous and solid for these. So we're going to apply our solubility rules. We need to figure out if our new products are soluble or insoluble. Let's start with iron hydroxide. Neither of these fit into our NAG rules. So this one is insoluble. It would be a solid. Okay, that's what insoluble means. So if we combine these 2 liquids, we should form a solid, and it would be iron hydroxide. Let's look at lithium sulfate. Lithium is a group 1, so this one would be soluble, which means its state would be aqueous. All right, the molecular equation is probably the hardest part of this, and it's all things that you know how to do. It's just kind of time consuming, and there are a bunch of little tiny things to pay attention to. Let's look at our ionic equation. So for the ionic equation, what you're doing is you're breaking down your molecular equation into its ionic components. Basically, when something is dissolved into a solution, especially an ionic compound, it breaks up into its ions. So we're showing what ions it's broken up to. And we want to include how many of those ions we have. So these subscripts and coefficients are going to be really important right here. So let's break this down. We're going to have 2 irons, and their charges are +3s. For our ionic equation, we need to know how many of each ion they are, and since they are ions, we definitely need to know their charges. So we have 2 irons. We had 3 sulfates. Excuse me. We had 6 lithium and 6 hydroxide. On our product side, anything that is a solid, you do not break down. You only get to break it apart if it is aqueous. So here we still have 2 FeOH3. But this is aqueous, so we are going to break it down. So we have 6 Li plus and 3 SO4 minus 2. Okay, so this is our ionic equation. Everything that was an aqueous solution or an aqueous substance got broken down. Okay, so we're going to think of this as the aqueous breakdown. All right, and so we're going to go through and look at all of these, and anything that is exactly the same on both sides of the equation, we're going to cancel out. So let's start with our iron here. We have 2 Fe plus 3, and over here, it's part of a compound. It is not exactly the same, so we can't cross it off. Next is 3SO4 minus 2. Over here, it is 3SO4 minus 2. They are exactly the same, so we're going to cross it off. They cancel each other out. Next is 6Li plus and 6Li plus. Once again, they have canceled each other out. And then 6OH minus. It is not 6OH minus over here, so we don't get to cancel it out. For our net equation, it is anything that is left over from our ionic equation. Anything that did not get crossed out, we basically write exactly how it's written down here. So 2 Fe plus 3 plus 6 OH minus goes to 2 Fe OH 3. And if you did it right, it should all balance and everything should be perfect. All right. That's a precipitation reaction. That is a lot of work for one problem, and I know it is, but I also am pretty sure that you can do it. So let's see if you have gotten all the tools that you need to solve these problems. We are going to go. It is time for you to try this all by yourself. So please read through the problem, pause the video, give yourself a few minutes to solve it, and come back when you are ready. All right, hopefully you've had time to work through this. I have also put down some work. I wanted to get going on this problem. So for our first section, our molecular equation, we needed to turn sodium sulfate and lead nitrate into two new products. So you'll see here, I wrote down their charges, I wrote down their states, and then I made sure I knew which ones I was going to pair up with each other. So sodium and nitrate are going to pair up, and lead and sulfate are going to pair up. And we can see that over here. I followed through on their charges. Sodium and nitrate are +1, -1. Lead and sulfate are +2, -2. So they already balanced each other out. They already added up to 0. I also needed to make sure my equation as a whole was balanced. And after going through a table, I could see that I needed to put a 2 here in front of sodium sulfate. And that was it. That's all this equation needed to be balanced. And then you'll see down here in purple that I have the states of everything, and everything is aqueous except for lead sulfate. It has none of our solubility components in it, and so it is going to be a solid. It is insoluble. For our ionic equation, we need to remember that we're going to break up anything that is aqueous. So here we have broken up sodium sulfate into its ionic components. We have also broken up lead nitrate. We have also broken up sodium nitrate, but lead sulfate did not get broken down because you can see here, very importantly, that it is a solid, so it does not get broken up. And so what we're going to do now is we're going to go through and cross out anything that is exactly the same on both sides. So sodium is 2 Na plus and 2 Na plus. It is exactly the same on both sides, so we're going to cross it out. Sulfate here is an ion, and here it is in the compound, so it changes, so it doesn't get crossed out. Same thing with lead, but nitrate does not change, so it's going to get crossed out. Our last step is to just take anything that did not get crossed out and write it down into our net equation. So we have SO4 minus 2 plus PB plus 2, oops, not a plus sign, goes to PB SO4, make sure to writing down that solid. So this shows us that what actually happened in this reaction was sulfate combined with lead to make lead sulfate solid. All right, I hope that explains a little bit about what our precipitation reactions are going to be looking like. If you go to your homework section, the assignment section, you will see that there is a precipitation worksheet in there for you all. I want you to go ahead and give it a try. I will be posting an answer key to that later this week. But in the meantime, I want you to try and work through all those problems yourself. Have a great day, everybody.